Hello everyone. As you all know, we are doing video lecture series based on the topic vector analysis. And in the previous video, we did line integral of a vector field. And I promise that in the next video, we'll discuss conservative field. But before doing that, I think there are two rules of thumb which should be and must be understood first, because they will be used in all our future derivations and other topics. So I think that before doing conservative field, there are just two rules which state that divergence of curl is 0 and curl of gradient is 0. These are the two rules and they are fixed. They are as such always. So I think we should try to understand these first before moving towards other topics. Okay, so let's get started with these two rules. Let's start with the first rule, which says that divergence of curl is 0. And this is true. Divergence of curl is always 0. So let's try to solve it mathematically and see whether this statement is really true or not. Now it's saying divergence of curl. So if we want to take curl, which quantity should we take? Curl is found of which quantity? Scalar or vector? Well, it is a vector quantity. We always find curl of a vector quantity. And same is for divergence. Divergence is always of a vector quantity. So let's take A to be a vector quantity. As we have written, A, which is a vector function, and x, y, z are in parentheses, which means that A depend on these three independent variables. And also you know that we can write any vector as the components, as its components along all the three axes. So this is Ax, which is the x component, Ay, y component, and Az is the z component. So this is our vector function. And now first what we are going to write is curl of A. Okay, so curl of A, and then we have to take its divergence. All right, this is the meaning. So how can we show it mathematically? Curl of A, that means del cross A, and then you have to take divergence, because it states divergence of curl is 0. So that means that first we will find curl of a vector, and then we'll take divergence of the result, and that result would come out to be 0. So divergence is shown like this with a dot. Okay, so curl involves cross product and divergence involves dot product, so we have mentioned like this. So first we are going to solve this curl of A. So we can write it as del dot. Okay, and then how to find curl? Of course, we have to make use of the determinants, and we are going to write I cap, j cap, and k cap. And since cross product depends on order, so that's why del is coming first. So we are going to mention the components of del first. So that is curly by curly x, curly by curly y, and curly by curly z. And further, A comes, so all the components of A. All right. So now let's solve it. Del dot will remain as it is. And now you know how to find the cross product. So first comes the I cap, and it will be the cross product between these two. So that means then comes the j cap with a minus sign, and you know j is the cross product between these two. Then comes the k cap, and you know k cap is the cross product between these two. This is it. So let's write it properly. How does it look like? So it's del dot I cap curly a z by curly y minus curly a y by curly z. Then we can bring this minus inside, or you can just put plus sign here, but then take care that we have to exchange these quantities. So if we have to bring a positive sign here, then we have to write curly ax by curly z minus curly a z by curly x. Okay, and then this k cap is again a positive quantity. So this is it. So this is the curl of vector A. And as you know that we always find curl of a vector quantity, and curl of a vector quantity is again a vector quantity. Okay. So now this obtained result is again a vector, and then yes, of course, we can find divergence of that, because for divergence again we need a vector quantity. You should always remember that there is just gradient which is found of a scalar quantity, and other than that the divergence and curl, they are always found of a vector quantity. So now this answer, this complete expression is a vector quantity. It is a curl of a vector which is vector A, and now we can easily find divergence of a vector. So now let's find divergence. We can write down what is the expression of del, which is this. We know our del operator, because ultimately it is going to have dot product with this final result. Now you know in a dot product, I cap always interacts with I cap, j cap always interacts with j cap, and k cap always interacts with k cap. Why? Because other than that, we have this thing equals to this thing equals to this thing as 0. And other way also, if we write j dot I cap or k cap dot j cap or I cap dot k cap, then that is also equals to 0. This is what we know from our dot product rules. Okay, so now I'm not going to mention all the product parts, because I know that whenever there will be I dot j or j dot k, k dot I, and this j dot I, k dot j or I dot k, I will obtain 0. So mentioning all those terms are totally useless. So I'm just going to mention where my I dot I and j dot j and k dot k are there, because they would give me 1. Okay, so I'm just going to mention those terms. Now see, if I interacts with I only, so I'm left with curly by curly x of curly az by curly y minus curly ay by curly z. Then again, j interacts with j cap only, so I have curly by curly y, and then inside the brackets I have this thing. And k cap also interacts only with k cap, so I have again this curly by curly z, and then these are the terms inside the bracket. Now you can see first of all that this seems to be a scalar, since there are no I caps or j caps or k caps here, so that means this is a scalar now, because divergence of a vector quantity always gives us scalar. So by this you can also check that yes, whatever the way you are solving, you are doing it correctly. This is a scalar quantity now, so we can simply multiply this curly by curly x or curly by curly y and curly by curly z with the quantities inside the bracket, because now there is no dot product left or no cross product is there. We have already used them. So now it's just simple multiplication, if you say, or simple partial differentiation. See, multiplication is only for convenience I'm using this word, but ultimately this means that it will be a partial differentiation with respect to x of the terms which are inside the bracket, and same for y and z. So this becomes curly square az upon curly x curly y minus curly square ay upon curly x curly z, then plus curly square ax upon curly y curly z minus curly square az upon curly y curly x plus curly square ay upon curly z curly x, and then minus curly square ax upon curly z curly y. Now these all are scalar quantities, and when you multiply, since all these are going to be just number, so if you multiply 2 with 3, you write or, and just let me show it like this. If you write this or you write this, the answer would be 6 always. Okay, so that same situation is here. So whether it's curly x curly y or whether it's curly y curly x, that means the same thing. Okay, similarly whether it's curly x curly z or it's curly z curly x, that is also the same thing. Curly y by curly z or curly z curly y, that is also the same thing. So that means we can cancel out this term, gets cancelled out with this term gets cancelled out here, and this gets cancelled out here. So that means what we obtain is 0. So this would apply for any vector. You can mention vector b, c, e, f, anything which depends on x, y and z. So ultimately the answer is that divergence of a curl is, if we try to understand this otherwise, like in physical sense, then that means that divergence of curl is 0. That if something is rotating, then you cannot expect it to diverge or to spread. If something is just rotating, obviously if you see that something is only rotating, it's just circling around, okay, then if you expect that it would spread out, then that is a wrong notion. Something which is rotating, you cannot expect it to diverge. So any vector field which is only rotating, then there is possibility that it will not diverge. But we also find situations where we find both rotations and the divergence. But this is how we conclude this statement. And otherwise, mathematically, if you want to understand it, then there is one more way, which states that if some quantity is 0, this implies that either this is 0, okay, like if we have any quantity, suppose we write x dot y minus z equals to 0, like this. In maths, whenever we face a situation like this, we say that either x is 0 or y minus z is 0. Same notion I am using here, that if this whole term is 0, so that implies either this del cross A is 0 or which can mean what? If del cross A is 0, that implies that A is irrotational, irrotational field. Whenever curl of any vector quantity is 0, then that vector quantity is said to be irrotational. Now there are two rules which state that if del cross A is 0, then that implies that A is irrotational. That vector A or the vector field A is said to be irrotational. And if divergence of any vector field is 0, then that vector field is said to be solenoidal. Here irrotational means something which is not rotating, and solenoidal means something which is not diverging. Okay, so from this expression that we have obtained, del dot del cross A equal to 0, we can conclude or we can infer that either del cross A is 0, okay, either this thing is 0, or you can also call it 0 vector, because if you would take divergence of a 0 vector, then also you would obtain 0. Alright, you also know what is 0 vector. So if this del cross A is 0, then obviously we say we can also write it as 0 vector, because we know that cross product always gives us a vector quantity. So if cross product is giving us 0, that means we are obtaining a 0 vector. So either way it's correct, whether you just call it 0 or you say it's a 0 vector, both are correct, because both would be meaningless, because if something has direction but no magnitude, then it has no meaning. And then we would say that, okay, divergence of any 0 vector would give us 0. So one thing is this, and if del cross A is 0, then that means vector A is irrotational field. So that means either vector A is not rotating, okay, or what is possible is, secondly we can write, or we can also write that our del cross A is solenoidal, because you know that if you find divergence of any solenoidal field, then the answer obtained is always 0. I hope you can understand this. Just by this expression we can directly infer this. Either del cross A is 0 or 0 vector, which implies that A is irrotational field. That means your field is not rotating. So obviously the curl obtained would be 0, and then divergence of any 0 vector would be 0. Or other thing can be that this del cross A, the whole expression, that means curl of a vector field is solenoidal. Okay, del cross A means that curl of a vector field is solenoidal. That means the vector field is curling, it is rotating, but it is not diverging. And if you find divergence of any non-diverging vector field, obviously the answer is going to be 0. So something is happening. So either of the two, like you are finding divergence of curl of a vector. So you are hoping both rotation and spreading. But this rule, this result says that something is not happening. Either the field is not rotating, or the curl, if it is rotating, then it is not spreading. This is the thing. By this expression, we can conclude these two facts, that either the vector field is not rotating, or if it is rotating, then it is not spreading out. This is how we can understand this. Now let's discuss the divergence of non-solenoidal. So if it is non-solenoidal, then it will not be 0 if your A is non-solenoidal. But if A is solenoidal, that means A is not diverging. So then there is no question of finding divergence. If we already know that vector field is not diverging, then if you try to find what is the divergence, then obviously you will obtain 0. So in that case, this would be 0. Now let's discuss curl of gradient is 0. Now you should know and you should remember that gradient is always found of a scalar quantity, and curl is always found of a vector quantity. So this would be that first we'll find gradient of a scalar quantity, and we say it is phi. So phi is a scalar function, definitely depending on x, y and z. So first we have to find gradient of phi. and then we'll take curl of it. Okay, which means first it's going to be del phi. Now you should know how do we represent gradient. It is always of a scalar quantity and there is no symbol in between. And then we'll take curl of it. That means cross product. Now let's solve it. So first this del cross will stay as it is, and this del phi means for this del it is I cap curly by curly x plus j cap curly by curly y plus k cap curly by curly z, and this would be operating on phi. Alright, so we get I cap curly phi by curly x, because in itself this del operator is incomplete. It always waits for this to fill this gap, because this tells that partial differentiation of x with respect to what quantity. So this is the expression now. Now as you can see, this result, so this is the gradient of scalar quantity, and this result has I cap, j cap and k cap with it. So that means this is a vector quantity. And we know that gradient of a scalar quantity always gives us a vector quantity, because gradient is itself a vector. It's a vector operator. Okay, so even if a vector acts on a scalar, the answer would be vector. And for curl, we want a vector quantity. We can always and only find curl of a vector quantity. So we have obtained a vector quantity, so this is totally fine. Now we have to solve this cross product to find the curl. And how do we do that? Again, by using determinants. So first I'm going to mention this, and then as cross product is order specific, so del is coming first, so I will mention the components of del operator first. And then comes this gradient of scalar function. So just we'll skip I cap, j cap and k cap, and whatever is there, that will be taken as the component. So this component becomes curly phi by curly x, then curly phi by curly y, and curly phi by curly z. We have to solve this. Now let's see. You know I cap, this will interact with this portion. So we have mentioned all these. And then j cap comes with a negative sign and it always interacts with this. This involves the j cap. So we have to write it down. And then comes the k cap, and k cap, these two terms. So this way we have obtained all these. And as you can see, we can still solve it. So just see what do we get. This is simply partial differentiation of this whole quantity with respect to y. Okay, and then we have minus sign and then partial differentiation of curly phi by curly y with respect to z. Same for all other. So we can simply open it up and write it as curly square phi upon curly y curly z minus curly square phi upon curly z curly y. Then we can write for z cap also. And then comes the k cap. So this is how it is. And now you can see this particular portion is simply a number. We will obtain just a number if you, because phi is a scalar quantity. So if you take one time partial differentiation with respect to z and then with respect to y, as phi is depending on x, y, z, so we will obtain some number. So that means curly y, curly z and curly z and curly y, they mean the same thing, because ultimately we will obtain a number. So we can cancel them out. So this gets cancelled, this gets cancelled, and this also gets cancelled. So This is what? This is 0 iota cap minus 0 j cap plus 0 k cap. So you can mention it as 0 vector or simply 0. So that means curl of a gradient is 0, because ultimately we know that curl of any quantity gives us a vector quantity. So obviously this portion, the magnitude portion gets cancelled, but I cap, j cap and k cap are still there. So we can write that okay, we have obtained a 0 vector. But usually we take 0 vector as 0 only, because if magnitude is not there, then 0 vector has no meaning in itself. Okay, so curl of gradient is also 0. Now again we can conclude something from here. This means that either this del phi is 0. And what does this mean? Del phi means gradient of scalar field phi, which gives us greatest rate of increase of scalar field. Del always gives us, gradient always gives us greatest rate of increase of function phi. But if that is 0, it means no increase in phi. That means our scalar quantity is just not changing. There is no greatest change being measured. So one thing is this, and because if that's the case, then curl of any 0 quantity or a vector would be a 0. If our magnitude is 0, we can write it that curl we cannot take of any scalar quantity. For curl we want a vector quantity, so obviously it has to be a 0 vector. But again we would get just the 0 as answer. Okay, so one way is this, or other way could be that this del phi is irrotational. That okay, some increase, some change is happening in the scalar field, but definitely it is not rotating. And if some field is not rotating, because del phi is ultimately a vector field now, it is a vector now, but it is not rotating. So if something is not rotating and you are trying to find the curl of it, that how much it's rotating, so obviously you would get 0. In that case also this curl of this thing would be 0 if this thing is not rotating. So then again, we can understand this expression in two ways. Either this del phi, which is a vector field in itself, is not rotating, means whatever field is present there, there is no rotation. If no rotation is observed, curl would always come out to be 0. Or the possibility could be that this del phi is 0, that the scalar quantity phi is not changing. There is no increase being observed in phi, and which is giving us 0, and then curl of is 0 vector is giving us 0. So either way we can understand this. So this was all about the divergence of curl of a vector field which is always 0, and the curl of gradient which is always 0. So I've thought that these two rules should be discussed first if we want to discuss the future topics, because we would directly use these rules in deriving various theorems and other derivations. So in the next video we'll discuss conservative field, and we will definitely make use of one of these two rules there. Okay, so this was all about these two rules of thumb, that divergence of curl is always 0 and curl of gradient is always 0. That's all for today. Thank you.